we're talking about the product and quotient rules. Okay, so here's, first of all, this is the product rule. So this can be a little bit confusing for students, for some students. Hopefully most of you will get that. So when you have the product of two functions, then you don't just take the derivative of each one. And you want to take the derivative of that product, then you have to do it this way. So like, for example, let's say that I had f of x was x squared and g of x was x cubed, okay? And so, of course, f of x times g of x is actually x to the fifth, right? So you know that the derivative of, so we know already that if you take the derivative of the product of those two, that's just taking the derivative of x to the fifth, which is 5x to the fourth. Okay. Now, if you take the derivatives of each of these separately, that's 2x and that's 3x squared. And if you multiply those two together, you're going to get 6x cubed, which is not 5x cubed. So you know that that's going to be wrong, right? But this is the correct way to do it. So, well, it's f of x. Okay, so it's f of x times the derivative of g of x, that would be 3x squared, plus, and then g of x is x cubed, times the derivative of f of x, which is going to be 2x. And that turns out to be 5x to the fourth, as that worked out. Okay, so now you might think, well, how does this work? Let me just give you a brief indication of how that works. So here's what we're going to do. We're going to let capital F of x be the product of little f of x times g of x, little g of x. Okay. So if we use the difference quotient, okay, that's limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, but then the capital F is these two right here, so that's this. It's that. Okay, now here's where it gets a little bit tricky. But all I'm really doing is I'm going to add and subtract the same thing. I'm going to subtract and add the same thing. So I'm going to subtract an f of x plus h times g of x. But then I'm also going to add an f of x plus h times g of x. So I get that. Okay, now this part is now I can take at that part I can factor an f of x plus h out, and I'm left with g of x plus h minus g of x all over h. And then this other part right here, I can factor g of x out, and I'm left with f of x plus h minus f of x all over h. Okay, and of course all that's together. As h goes to 0, this one goes to f of x, as h goes to 0. That just goes to f of x. This one goes to g prime of x, because that's the derivative. This of course just stays as g of x, and then this one of course becomes f prime of x. Okay, and so that's pretty much the product rule right there. There's other ways of looking at this that might be more intuitive. You can look at the book for some other example. They use like this rectangle, adding area to both sides of a rectangle to kind of show you how that works. And that's a good way to look at it. Okay, so that's the product rule. We also have the quotient rule. That's if you have one function divided by another function. Okay, now one way that a lot of people remember this is this part is from the bottom, right? So people say low. They say the g of x is like low. And then this part right here is the f of it is the high part. Not right. Okay, so d high. Oops. And then this part right here is minus the high, d low. Okay. So minus high d low. Okay, and then down here, over here, it's over the square of what's below. Okay, so over the square of what's below. So it's over g of x squared. So the square of what's below. Okay, so that's one way to look at that part right there. Okay, so that's the product rule and the quotient rule, how you deal with those. Now let's go ahead and we're going to apply those to some problems. So first of all, this first problem here, let f of x be this product. Find the derivative by using the product rule and then by multiplying first. Okay, so by using the product rule, we have, let's go back really quick and take just a really brief look at the product rule. So it's the first function times the derivative of the second plus the second function times the derivative of the first. Okay, so this one is like your first function, although the whole thing is a little f. Okay, and so this is the first function times the derivative of the second one, which is 1 minus 2x. Okay, so the derivative of x is 1, derivative of 2x is, bring the 2 down, reduce that by 1, so you get 2x. Plus the second function times the derivative of the first. Okay, the derivative of 1 is 0, fortunately, and then the derivative is going to be, you bring the 2 down, so that's 16, and you reduce that by 1, so 16x. Like that, and then we multiply it out, so that times that's 1. The outside is minus 2x. Inside is plus 8x squared, and that last one is minus 16x cubed. That's the first one. This one, you distribute the 16x in. So you have plus 16x squared minus 16x cubed. Okay, so in the end, you have negative, so the x cubed terms, there's minus 16 and a minus 16, so that's negative 32x cubed. The x squared terms, that's going to be plus 24x squared, and then the x term minus 2x, and then plus 1. That is using the product rule. Okay, now multiplying first would mean we expand all this first before we take the derivative. Okay, so if we multiply the first two together, that's just going to be x. The outside is minus x squared. The inside is plus 8x cubed. And the last terms are minus 8x to the fourth. And then we take the derivative. let's start with the, I guess we can do this term first. Okay, let's do it in order. So the derivative of this is 1. The derivative of this is minus 2x. The derivative of this, you bring the 3 down, that's 24. Okay, 3 times 8 is 24, and then this reduces by 1. 4 comes down, that's 4 times 8 is 32. And 4 minus 1 is 3. Okay, so you get the same thing either way. In this case, probably multiplying it out was actually easier than using the product rule that we just learned. Okay, so those would be the answers. And then do they agree? Yes, they agree. Of course they agree. If you do it correct, then they're going to agree. Okay, let's take a look at number 2. And we're supposed to differentiate this. It's easier. So when you have like these powers of y or whatever, or x, so in this case, y is the independent variable. And so then if you've got powers of that in the denominator, then you can rewrite it as being in the numerator, but we just put a negative exponent. Like that. Okay, so 1 over y squared is the same as y to the negative 2. 9 over y to the 4th is the same as 9y to the negative 4. Okay, now if you want, you can multiply these out and then do it, but let's use the product rule. Maybe it's, okay, so I always look for the easiest way to do these things. And right now I'm thinking I shouldn't have done what I just did. You know, I'm gonna start over. I'm just gonna start over. Let me erase all that. Yeah, I have to start over sometimes because I guess that's what if you guys are doing things correctly and you're having experiences that I have when I was going through calculus, then you're facing a lot of frustration and a lot of starting over, right? Unless you're like really perfect and you like never start over, you always get it right the first time, but I really doubt that happens. Because a lot of the times, I would say like a huge percentage of the time I have to start over. Okay, so here, let me show you how to do that. Okay, so I'm going to multiply these together first. I think that's going to be the easiest way to do this problem. Okay, so the first ones, multiply those together, and I get a 1 over y. Then the outside one, so this times this, is going to be 3y. Because I have y cubed over y squared, so that's just going to be y. Here we have minus 9 over y to the 3rd, because there's a y, and then in the numerator, a y 4th in the denominator, so that those reduces. And then this and this is going to give you minus 9 over y. And I suppose that I can combine the first and the last ones. So that's negative 8 over y. And now I want to write it. We want to put y's in the numerator with negative exponents. Okay, so I want to bring these up to the numerator and put a negative exponent. Okay. So f prime of y. Okay, so now we can take the derivative. So here I'm going to bring this negative 1 down. Negative 1 times negative 8 becomes positive 8. Then negative 1 minus 1 is negative 2. The derivative of this is just 3. This one, I bring the negative 3 down. So negative 9 times negative 3 is positive 27. And then negative 3 minus 1, that's negative 4. So I get that. Hold on, I made a mistake here. I made a mistake. 9 times 3 is 27. I'm sorry. So that means that this is 26. So 1 minus 27 is negative 26. So this becomes 26 here, and that's a 26. So 26 y to the negative 2 plus 3 plus 27 y to the 4th. Or you could write it as 26 over y squared plus 3 plus 27 over y to the 4th. Yeah. Okay. Any questions on that? Okay, let's go to this problem here. So here, we have a quotient. So now we can try the quotient rule. Okay, so let me refresh your memories. So you got a function on top and one on the bottom, high and low. You're taking the derivative. That's going to be the one on the bottom times the derivative of the top one minus the one on the top times the derivative of the bottom one. Okay, so low d high minus high d low over the square of what's below. Okay, so in this case, this 8x is our f, and our e to the x is our g. So the bottom one, low, d high, so the derivative of 8x is 8, minus the high, which is 8 to the x, times the derivative of the bottom, which is just, the derivative of e to the x we learned it last time was just e to the x. All over the square of what's below. So e to the x squared. You can also write it as e to the 2x, okay, like that. But maybe it's easier not to, because right here as it is, I have an e to the x here and I have an e to the x there. So those factor out as e to the x. And e to the x squared is just e to the x times e to the, times itself, right? So that means that this and this are going to cancel with each other. And I have 8 minus 8x over e to the x. This could also be written as, you can bring the e to the x to the numerator and make that an e to the negative x if you wanted. You could probably factor an 8 out as well and do like that. That would probably also work. Okay, great. Let's look at number 4. This also looks like a quotient rule. This is a complex fraction, meaning what that means is that one of the numerator, the denominator, also has some fraction in it somewhere. And it's, in this case, the denominator has this fraction right here. So this means this is a complex fraction. And so if that's the case, it's generally going to be easier to differentiate this if we simplify it to a non-complex fraction. And you can do that by multiplying by x over x. Because this denominator is x, that's the only denominator that there is. So normally you would look through, find a common denominator from here, and looking at all these terms, find the common denominator, and it's just x, and then multiply the numerator and the denominator by that. And so when you do that, up here we have x squared, down below we have, as you distribute the x in, x times x is x squared, x times c over x is just c. Okay, so I really have this right here. And so now, let's go ahead and differentiate that. That's our f. And that's our g from the quotient formula, the quotient rule. Okay. So the derivative. Okay, so it is the low part times the derivative of the high part, which is just 2x in this case, minus the high part, which is not that. It's the high part is just x squared, times the derivative of the low part, which is 2x. Okay, so derivative of this is 2x, derivative of a constant is 0. All over the square of what's below. Like that. Okay, so now if we distribute this in, we have 2x cubed plus 2cx. Okay, so that's this times this, it's 2x cubed. This times this is 2cx. Minus 2x cubed. Okay, wow, I can't wait. I'm hurrying really quick. Now, I get to cancel some things. Yay, that's my favorite part. Those cancel, and we end up with just 2cx over this x squared plus c quantity squared. Okay, great. That's number 4. So let's look at number 5. Find f prime of x and f double prime. So this is the first derivative and the second derivative. Okay, so here's our function. This is the product rule again. Now, if I write these, I can rewrite the product rule this way. And this would be u times the first one plus the second one times the derivative of the first one. So u dv plus v du. And this would be our u, and that would be like our v. Okay, and I guess that would be dv dx or du dx. You could just leave it like that. Like you can just leave it as dv or du. That's also acceptable notation. Okay, so the derivative. So it'd be u times the dv. So this part times the derivative of this part, which is just one, which is itself, plus this part, e to the x, times the derivative of this part, which is 3x squared. Okay, now these are all being multiplied by e to the x, right? So that can factor all the way out, and everything else goes in. Okay, so that should work right there for the first derivative. Okay, now for the second derivative, that becomes our u, and that becomes our v. So we have, or I guess I could have read it the other way around. I could have read the e to the x at the end. Maybe I should have done that. Oh, well, too late now. Okay, so I have e to the x times the derivative of that. So that's 3x squared plus 6x plus 0 plus all of this times the derivative of that, which is just e to the x. And again, And again, we have these being the same. And so basically we just add the other part. So we just add all that and plus all that, and it looks like x cubed is the highest term. Then we have 3x squared and also another 3x squared, but 6x squared. And then we have a 6x, and we have an 8. Okay, so that should be the second derivative. Well, someone erase the x. Okay, great. Let's move on to the next problem. Find an equation of the tangent line to the graph of this at the point 1, 0. So here we have a quotient. Here's the high part. Here's the low part. And so the derivative use the quotient rule. So it's low, which is this one, times the derivative d high. So the derivative of this is 2x minus 0, or 2x, minus high d low. So the derivative of the denominator, that's 2x plus 1. Okay, derivative of 2x is, or x squared is, you bring the 2 down, and then you reduce that by 1 power, so that's 2x. And then the derivative, that's just 1. All over the square of what's below. That would be x squared plus x plus 1 squared. Okay, so now this is pretty complicated, but they say at the point 1, 0. So that means you're going to set x equal to 0 in that equation. Okay, so that means you have, when you set x equal to 0, that's 0. It turns out that's 0, everything's 0 anyway, so that first term's all gone. Here, this minus, and then you have, make that 0. And then down here we have 0, or 0 squared plus 0 plus 1. And minus, okay, so here this is -1 times 1, that's -1 times -1 is 1. And then down here, this is also 1. 1 squared is 1. So it's just 1. Also, generally what I do, just for completion here, is I'm just going to verify f of 0. So no, f of 1. So if I put a 1 in here, I have 1 squared minus 1 over 1 squared plus 1 plus 1. So that's going to be 0 over 3. That's going to be 0. So I don't know what I'm thinking. I'm kind of off today. I am off today. Oh my goodness. Okay, that's just verification that when we plug a 1 in for x, we get a 0. Okay, so here's the problem. X is 1, not 0. Set x equal to 1, because that's your x, right? And the 0 is your y, is your f. So if you plug a 1 in for x, then you get 0. So I was supposed to plug a 1 in. So I'm plugging it in right here. Okay. And I'm not going to get that. Nope. Okay, so this becomes 3, and that's 2 still. And this becomes 0, and that's 3. But it doesn't really matter because that's the whole thing's going to be 0. And this becomes 1 squared plus 1 plus 1. That's 3 squared. So that's 3 squared. Okay, and then this right here goes away because that's just 0. So, and then this one reduces one of those, so you get 2/3. Okay, so the derivative is 2/3. That means that the slope is 2/3. So, and we want we want to get the line that is tangent, right? Tangent line. So we know that the slope is 2/3. So you can start like that. And then we plug in the 0.10. So that means you plug in a 1 for x and a 0 for y. Okay, so that becomes 0. And that becomes 1. So b is negative 2/3. And then just plug that b into here. Okay, so that was pretty complicated. Now let's look at number 7. Their notation is it's at x equals 2, at x equals 2. So what they're trying to do here is kind of write it as f prime, or like if this function were f, they're trying to find f prime of 2. Okay, and so the notation is to write a vertical line like that and then an x equals 2 at the bottom. But that's really just like taking the derivative and then evaluate on x equals 2. Okay, so first of all, let's, this is a quotient. So let's just take the derivative, then we'll plug the 2 in later. Okay. So this is high, h of x, low is just x. So low d high, so low, which is x, times the derivative of the high part, which is h prime of x, minus high times the derivative of the bottom. Now the derivative of the bottom, the x is just the bottom, and so this derivative is just 1. All over the square what's below. Okay, so far we have that derivative is x, h prime of x, minus h of x, all over x squared. Okay, so what we're going to do is at x equals 2, so that means we're going to substitute everything, we're going to substitute 2's in there. So I'm replacing all these x's with 2's, basically. Okay, now we know that h of 2 is 8. That's this one. And we also know that h prime of 2 is negative 3, and that's this one. And so this one gets replaced with a negative 3. And this one gets replaced with an 8. Like that. Okay, so we have -6 minus 8 all over 4, which is -14 over 4, or -7/2. Does that look like a lot of fun? Of course it looks like lots of fun. Okay, so number 7. There's not number 7. Okay, now number 8. Find P prime of 2. Okay, so P is the product of these two, right? Okay, so P prime of 2 is going to be, okay, so you take the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, so now let's take a look at what f of 2 is. Here's 2 right here. So we know f of 2 is 3. That's the 3. We know g of 2 is 2. There it is right there. Okay, now we want g prime of 2. So to get that, okay, so right here's 2. We want g prime of 2. Okay, so this is just a line segment right here. So G is basically a line segment right here where we want that, and it goes from here to here. We can look at it going from there to there. So it's going up by 2 and across by 4. Okay, so at that point, the slope is 2 over 4, or 1/2. Which means that this is 1/2. Meanwhile, here, f prime of 2, here's f of 2 right here. It appears to have a horizontal tangent, so the slope is 0. Okay, so the answer to that part is going to be 3/2. Okay. So 3/2. Okay, now for the second part, we're going to use the quotient rule. So this is high, that's low. So high, so g of 7 times the derivative of low, that's f prime of 7, minus the high part, that's f of 7 times the d low, so that's g prime of 7. And that's all over the square of what's below, g of 7 squared. Like that. Okay, so now we're going to substitute everything in. So let's start with this g of 7 first. Okay, so g of 7. So here's 7 right there. G of 7 is 1. Okay, so that's going to be a 1. F of 7 is, okay, so let's see. G of 7 equals 1. Here, F of 7 is going to be 5. Okay, so that's going to be -5. Okay, but we still have other, oh, and then this is also going to be a 1. Oh, that's nice. There's part in the denominator here. Okay, so now let's take a look at the other aspects of it. Okay, f prime of 7. So here's 7. It's part of this line segment here. And it goes through that point and that point, it appears. So that means that it goes up 1 and across 1, 2, 3, 4. So here, that's going to be f prime of 7. Okay, so that becomes 1/4. And then we're looking at this slope right here. And it goes through that point and that point. That's not clear what that point is right there. And it goes down by 2 and over by 3. That means g prime of 7 is negative. It goes down by 2 and over 3, so negative 2/3. Okay. Well, I didn't leave myself very much room. Okay, I'll just go up here and do it. Okay, so that means we have 1/4. Okay, minus 5 times negative 2/3. So this is actually going to be plus 10/3 all over 1. So you can just basically ignore that one, and then just that gets 1/4 plus 10/3. And I guess that you can. The common denominator would be 12. So this is 3 over 12 plus 40 over 12, or 43 over 12. Okay, so that was number 8.